Yeah, that
Um,
sounds good to me.
yeah, let me just share my screen and we'll be good.
All right, sounds good.
Yeah, thank you for turning on your camera if you can.
Yep.
Um, Let me just get my screen shared. Okay, can you guys see my screen?
Yes, we can.
Yeah. Okay, great.
Yes.
Um, so we're gonna get started right now, and we'll just go with it. If you have any questions, just feel free to type it into the chat at any time, or even just to kind of like just unmute yourself and just shout at us. Not like literally, but like you get the point. Just let one of us know. Ask us. So I think without further ado, I think we can start now.
Yeah, let's start.
Yeah, great. So the history of computers. Um, just before we start, actually, just want to thank you guys again for coming out tonight. It's a real pleasure to kind of share some knowledge, and it takes dedication on a Sunday night to come out and actually be willing to learn something. So great. Okay, so before we start our lesson, let's just talk about who we are.
Yeah, so we want everybody here to feel included and feel good about who you're being taught and everybody who's teaching you. So I'm Gary Wang. I'm 13 years old this year. I like McDonald's as my favorite food. Yep. And I like gaming and reading.
Great. My name is Ivan Sun. I'm 13 years old as well. My favorite food is sushi, on the other hand, and I like to swim. Great. Now, let's go on to the next slide. So the icebreaker. So if you want to go around and you can say your age, your favorite food, and why you chose this class. So we'll start off with just anyone just unmute because we're gonna get to everyone. So you might as well just volunteer yourself before I volunteer you.
Yeah. Anyone want to go first?
Yeah, I'll go first.
All right.
I'm 8 and I like sushi and I just came here because I don't know where else to go.
Yeah, good job. Yeah, thank you
Wow,
for sharing about yourself.
that's great.
How about David? Why don't you also introduce yourself?
Um, my name is David. I'm 7 years old. I like pizza and I I like watching movie and reading
All
and
right. Yeah.
and why'd you come here? Why'd you choose this class?
because my my brother said I should come to this class to learn more.
Great.
Oh, there's another
Someone just joined
person.
us.
Yeah.
Let's just wait. Maybe we want to introduce ourselves again. I don't know.
It's fine.
Um,
You just
mm,
will or continue.
we'll give this person 10 seconds.
All right.
Okay. Um, for whoever just joined, my name is Ivan.
And
And my co-presenter here is Gary, and we're going to talk about kind of the history of computers, how they've actually that's in the next slide. So you'll see what we're going to talk about later. And for who just joined, Freya. If I'm butchering your name, just let me know. Could you unmute yourself and kind of just as a icebreaker, tell us how old you are, what your favorite food is, and why you chose this class?
if not,
Hi,
yeah.
sorry, Freya's still in the washroom. She'll be coming
Oh,
out soon.
yeah, no problem. No problem.
Thank you.
Yeah, no problem.
And Daniel Cow actually joined us as well.
What?
So
Sorry, where's Daniel Cow?
never mind, he left. It's fine. I think we'll just. Oh, there's actually more people joining, so I think we should just. Okay, 10 minutes late, but okay, better late than never, maybe.
We'll just let them in. We'll just
For
wait.
whoever just joined, so George, my name is Ivan, and my co-presenter here is Gary, and we're going to talk about kind of the history of computers and computers in general. So if you could unmute yourself and kind of for the icebreaker, just tell us your age, your favorite food, why you chose this class, that would be great. And if you guys can turn your cameras on, that would be great as well. No. um,
It's okay if you don't want to share. We get it. There will be many other chances in the future to
but just like if
express
you
your,
want,
your
or
yeah.
anybody who just joined, your age, your favorite food, why you chose the class, just kind of get to know each other. And if you weren't here for our introduction, my name's Ivan.
And I'm
My-
Gary. But yeah, I think we should continue, Ivan.
yeah, okay, it's
let's
fine.
continue.
If they just come in, they'll figure it
They'll
out.
figure it out. Yeah.
Hopefully. Where is okay? We moved that slide, but oh well, we messed up, but it's okay.
All right. So
Our class timeline. So class 1 will be the history of computers, which is today. Class 2 will be the history of the internet, which is next week, same time. Class 3 will be parts of a computer. Actually, we'll cover parts of a computer today, but we'll go into more depth if you're interested in 2 weeks from now. And then we'll also, in class 4, you can choose what you want to do. For example, like if you want to learn about cryptocurrencies, NFTs, or if you're
Ivan,
curious,
can you please explain to them what NFTs are?
it's kind of like a digital form of artwork or just any digital copy of something normally artwork that you can sell online using like cryptocurrencies, but that's kind of just the easiest way of explaining it, but we can go in depth eventually. So if you have any questions right now, just unmute yourself, let us know. It's a safe space. You don't need to worry about anything.
Or you can type in the chat and you can monitor it. Okay. Yeah, next slide. I don't think there's any questions. So today we're gonna learn about 4 things. We're gonna just cover it generally, skim through it. First one is the invention of computers. Second one is how they have advanced. Third one is how people use it in the past and today, and how they might use it in the future, as well as finally just a little skim through of what parts of a computer's part of a computer are and how they benefit us.
Great. Let's move on. So our learning goals for today, I understand when, why, and how computers were invented. I understand how they've evolved to be what we know today. I understand how people used to use a computer versus now, and I'm able to recognize the basic parts of a computer.
Now, quick thing I just want to say, starting from the next slide, there's going to be some big words or some concepts or like things you might not get. If you do not get what that means, it is okay. It's a safe space. Just you can raise your virtual hand or you can type it in the chat or you can just unmute yourself and cut us off. That is all perfectly fine and ask your question. All right, next slide, Evan.
Yeah, there's actually, we have to go back because someone moved a slide. So we'll just start here. So how do computers work? Computers work by inputting commands from the user, and it provides an output, usually from a screen or any other output device, and it follows like the instructions that you input into it. For example, you give the computer instruction to type Apple on the computer, and you see the input, and so you input the letters for Apple, and the computer outputs it on the screen. And computers have little things called microprocessors that instantly make calculations or commands. In fact, lots of things in our lives have them, such as cars, washing machines, televisions, and so on. So these little microchips, or microprocessors, they're they're evident. They're in a lot of things we use, and just some context in terms of the world. There's actually a global chip shortage right now, the biggest one that's like in a long time, or maybe just in history. And so lots of gamers, lots of work stations, biz enterprises, they're not able to properly be equipped with the necessary equipment such as the graphics cards, central processing units, and this affects the car manufacturers too, because a lot of cars with new microchips in them, they're not able to be rolled out of the factories as well. And computers, moving on through the slide, computers also have memory. This is usually called RAM, which stores items on the computer that are not in use. Basically, it's like a closet where you put everything you don't need in it. Pardon the typo, and you can take it out and access it where you left off. And as computers run, they get hot, so computers have fans normally or heat sinks, cooling devices to cool them off. So let's just move back to the next
Timeline. Ivan, go to the timeline. All right. So this is a computer timeline, the history generally of computers. We're gonna get into some advanced technical terms, concepts. So once again, if you don't know anything, just interrupt us. Yeah. So first, 1936, the first computer was made. This was a programmable computer. So like one of those like so very slow, one of those ancient kind of computers, like the typewriter kind of things. So that was like the first type of computer. 1947, they made something called the transistor. The transistor was invented by Bell Telephone Company, and it wasn't a computer, but it was like a little vital computer component. So like it was like part of a computer that you would need to function a computer. In 1956, 1953, the IBM came out, which was the International Business Machines, with their first ever computers. So back in the day, not everybody could use these computers. They were mainly used for businesses, those giant buildings and like people just typing on the computers. They were used for those places. And in 1953, it first came out. In 1955, bankers got their own type of computers. They got the bank computers. This was the first ever type of banking computer that came out. Like those computers the bankers use. They used MRIC or magnetic ink character recognitions to read the checks. Perhaps like for example, what this means is let's say you give somebody a check, right? Like give a banker a check. They use these computers to read if the data on the check and how much money you need. And so in 1958, the computer chip came out. Jack Kilby and Robert Noyce invented an integrated circuit, better known as the computer chip, which is just once again another component of the computer, just like the transistor. And they're vital parts, meaning essential, meaning important parts of the computer. In 1962 was when video games first came out on these computers. The Playboy. There's the those Pokemon. Those pixel games. Yeah, that's when video games first came out. There were some good games back then. 1963, just 1 year after, the first mouse was invented. So Douglas Elgerbert actually invented mouse. He called it the mouse because the cord came out like the back tail. You know how a mouse has cord? It looks like a mouse's tail. So when they say mouse, they mean like just your random mouse. So in 1969, the internet came out. That's what we use today. What we're going to cover next class. We generally know what that is. From 1974 to 1977, the first personal computers came out, meaning that it was not only limited to bankers and businesses anymore. Anybody can use these. And so generally in 1975, this was when Bill Gates and Paul Aaron, you probably know who Bill Gates is. If you don't know, he's the CEO of Apple. And so that's when they first came out. In 1989, Microsoft, which is, oh, sorry. Yeah, my bad. Microsoft is Steve Jobs owns Apple. It's my bad. That was a mistake I just said. Steve Jobs was the person who made Apple and owns Apple. Bill Gates is the one who owns Microsoft, right? So in 1989, Microsoft expanded. They made their Microsoft computers, which some of you might have, Windows computers, that's theirs. And so in 1991 is when the internet, which we all know right now, how you're going to this class, what you're Googling, came out. In 1991 as well. Oh, Ivan just did something.
I'm very sorry.
Ivan, come on now.
Just to interrupt. I'm pretty sure Steve Jobs was the former of Apple. I don't think he owns Apple anymore.
Yeah.
But there is a new CEO, I believe Tim Cook. or don't quote me on that, maybe. But like, yeah, the rest is good.
Yeah, so we're almost done here. 1991, first laptops came from the PowerBook 100, and this was like the first ever laptop. There were other portable computers before this, but they were very chunky and very like big and expensive, and nobody could barely use them, right? 1996, the Worldwide Convention came out, the first internet convention, basically a convention about like the internet, things like those. In 1996 as well, mini computers, aka what we use today, ones that are compatible with the internet came out. So you guys don't have to memorize this. This is just some timeline for computers. Do any of you guys have questions? I know there are some big terms, there's some confusing
Yeah.
things.
Before that, like, this is just kind of like the past stages of the internet, sorry, the computers and the internet. And just from then on, it's basically the creation of kind of smartphones, the creation of more lightweight, thinner, portable laptops, and just more powerful processing units. But these are kind of some main ideas from before 2000. Yeah, so any questions? Again, you don't have to remember this. It's just there for your reference information. So if we don't have any questions, I think we're gonna move on. Great. So the first stages of a computer, they're made for like just specific jobs. They're very heavy, difficult to use, and there are only a few parts in the computer, and they're actually quite difficult to use as well, and not very straightforward. Like the operating systems in computers such as Mac OS, Windows we have today. So I will move on. The next steps, then computers started advancing over time, like many like good ideas. More parts were added, more functions. They were able to access better, larger applications. They were able to have better processors, more powerful processors that could conduct larger jobs, and they became more accessible. So anyone who wanted one, or who could afford one rather, was able to buy one. And then the final results. So nowadays computers have over 10 parts. I would actually argue way more than 10 parts if you're counting each specific like thing that consists of it. But they're accessible for everyone, and it is easy to use. Great. Now, we're just gonna stop and ask some questions, some some questions I'll build onto our presentation. So, how do you use a computer? So just feel free to. We're gonna go through at least 2 or 3 people, and just feel free to raise your hand or just unmute and tell us. If you don't volunteer yourself, we'll have to volunteer you, and I don't like. It's just better if you wanna.
Yeah, we don't like doing that. It's not a good way to do things. Anyone? All right. If not, Ivan, why don't you pick one and then I'll pick up.
Okay.
I'll pick one as well.
George, could you unmute yourself and tell us how you use a computer in your daily life? Um, okay.
How about David? How do you use a computer or any device in everyday life?
I don't know.
Here, like, do you search the web? Do you read any ebooks? Do you play any games on your computer?
I watch YouTube.
Great. YouTube is a great learning resource application, and it's good for entertainment as well. So that's cool. I'm gonna volunteer someone else. Freya, just tell me if I'm pronouncing your name wrong. Could you unmute yourself and tell us how you use a computer? No. How about Brenya? Would you like to unmute yourself? and step up to the plate.
I use my computer for school.
For school, great. Would you like to elaborate on that? Like, do you use it for like on Google Docs for typing, something
I
out, or?
use it for the apps my teacher gets me.
All right, cool. That's great. Yeah, just we're really trying to encourage everyone to kind of answer a question. It's good engagement and it doesn't hurt. There's no right or wrong answer in this class. So that should, yeah, that's great. So next slide.
Sorry, but I think you're the one screen sharing, not me.
I am actually. I just said that. Um, how do you guys think people use computers in the past? We actually gave some sneak peeks or some hints when Gary was describing the timeline, but it doesn't hurt to reiterate. So yeah, how do you guys think people use computers in the past? It would be great if you could volunteer.
What Ivan is trying to say is like, how do you think people back then, perhaps let's say like 1984, how do you think people use computers then? Do you think they were playing video games on it? Do you think they were on the internet? Do you think they were doing homework on it? What do you guys think they did back then with the computers? There's no right or wrong. There is no right or wrong.
Maybe they play games.
Yeah, definitely. During 1984, like we said, video games were already out. I believe there was like those
There were
pixel
like
arcade games.
not
So
like yeah, not like games.
not full on games nowadays. Like
Not like games you
pixel
see
arcade
today. They're
games.
like really simple games. Let me one second.
Like Tetra, Tetra, like building the blocks. They're falling from the sky and you try to build them together. Things like those. Yeah. So good job, David. Yeah, that's one. Anybody else? Ivan, why don't you have to call?
I think it's actually called Tetris, Gary.
Yeah. Okay. Same thing. Yeah. Whatever. Okay. All right. You
yeah.
pick on one.
I think I'll pick who just joined us. What's this person's name? Jimmy.
Jimmy.
I'm gonna force you to talk. Could you please unmute and answer the question? How do you think people use computers in the past?
How do you think people use computer in the past? What do you think? What do they do? They play what?
Yeah.
Jimmy is only 6, so
yeah,
he probably thinking of 7 years ago.
Yeah.
What do you think they're doing things in the
just there's no this class is great because there's no right or wrong answers. It's really just
what do you think they do in the past? Play games. Yes,
Play games?
Yeah, great.
I said that.
Okay.
It's fine. It's okay.
Pay bill.
Do work?
Yeah, exactly. Back then.
Calculate.
Yeah, exactly.
Great.
Back then, in fact, way back then, like 1938, when computers were first invented. You're right, Jimmy. They're used to work. They're used to calculate because they were actually meant to be used to be calculated. You can see in the computer you can see at the picture in the screen. They were meant, they were very chunky. They were meant to be used to do business. So good job, Jimmy. You got that one right. Good job. All right, I think we can.
Yeah, actually, computers were more specialized in the past. Like the further you go, like there's a computer made specifically, let's just say, for calculations, or one specifically just for like banking or reading banknotes, or checks specific. Checks. So that's really cool. Yeah, so great answer. Let's move on. Gary, I think you can take this one.
Oh, all right, sounds good. So all right, didn't you already do that? Okay, you didn't. All right, so now we see how computers have advanced through the years. At the very beginning, right, computers were very slow. They were very large. You can see in the image. Before this, they were giant computers. They weren't really meant to be for the internet or for playing video games at all. They were meant for bankers and they were meant for businessmen to help the economy, which is basically how people earn money, how the society, how like buildings get built, right? So economy and things like those, right? And over the years, though, computer scientists. So those scientists, you may know what they are. They're people who do a specific thing, right? So computer scientists, people who research computers, have improved the computers to become both smaller. So we can see like laptops, right? Like little keyboards, right? So because they can get smaller and they have made it so that it is now faster. So it's not very slow and like it doesn't take a lot of time to, click on a website and wait. And finally, these advancements have enabled more advanced tasks to be possible, meaning that these advancements, these computer scientists have made, has helped make tasks back then easier. So, for example, back then, you'd say like perhaps building a giant robot was very hard, right? Programming what the robot could do was very hard. But now, since computers are made, laptops are smaller, they're faster, they're better. It's much easier to make these robots and program them.
Yeah, great. Sorry for correcting you, Gary, but I think business people would be a better term.
Yeah.
But I understand. But anyways, I think we are gonna pick up the pace here because we're running out of time. So let's just do this faster. So, what do people use computers for? The reasons why people use computers is for speed, because you're able to get work done way faster through typing rather, and automated programs. Reliability, instead of like kind of just getting a piece of paper and forgetting about it, maybe throwing it away one day. A computer, if it's stored there, if you save it properly, it's always there unless you delete it, obviously. Consistency, like every day, you know that there's going to be a keyboard there unless you take it or someone takes it. You know that a program's other always going to generally look similar unless there's like a major update, but that's very rare. And for storage, it's way easier, again, like same as reliable. Kind of adding on to reliability. Storage allows like you to store your files, the important data you need all in one place, which is very good. And communication is a plus as well because you're able to easily communicate quickly with people via email or text message. Great. So next slide. So some fun facts about computers. Gary, if you would like to tell us.
Yeah, sounds good. So, fun facts about computers now.
Just go through a few of them, maybe like 5 of them.
All right.
I believe they're under the speaker notes.
Yeah. So, here's 5 very fun facts. Basically, did you know that Microsoft, Apple, all these big companies, they all have one thing in common, right? There's different types, they do different things, but one thing they all have in common is that they all started in a garage, meaning that these companies, these giant businesses, they all started in where you store a car, in a garage. That's where these companies started. Another fun fact is that actually the original name of Windows. So Windows, you may not know what that is. Like it's a type of computer, right? Window computers. Um, they were first actually called Interface Manager. I don't know if that's a fun fact or not, but I thought that was pretty interesting, right? And then there's another fun fact. I'll just say one more fun fact. The first ever. So we know that Doug Elgenberg, right? He was the one who made computer mouses, which I showed you before, right? Things like these, right? He was the one who made computer mouses. The first ever computer mouse was made of wood. We see mouses nowadays are made of like, things very light, plastic, but back then they were made of wood. All right, Ivan, you can do next slide.
Great. So which parts of a computer do you know? Would you like to, like hardware wise, would you like to unmute yourself and just tell us?
The screen.
Yeah, the display or screen, commonly known as a screen. That's a good part. Anyone else more of like the hardware components?
There's batteries.
Yeah, great. That's more commonly in a laptop compared, or like in a mobile device compared to a desktop computer. But yeah, that's correct. Anyone else?
Does anyone know any computer parts? Brenia, sorry, correct me if I'm wrong. I don't know how to say that name. My bad. Do you know any computer parts? No, that is completely okay then. Ivan, next slide, please.
Great. I think I'll go through a few slides and Gary can go through a few slides, and then we actually have a fun video at the end, or two great videos, and hopefully you learned something from it. But yeah, next slide. So the first part, essential part of the computer is a CPU, or the central processing unit. So it's basically where all the main tasks get sent there, from your, like, what you get from the internet and it, or from the storage, and it gets sent here, and it basically gets sorts the information and takes it to where it needs to go to be, and it also processes the information as well. So that's great. There's also APUs, or accelerated processing units. This is a term used more commonly by AMD, which is um, a CPU manufacturer, and their Ryzen line of chips, because these APUs is a mix between a CPU and they have GPU. They're also like, they have integrated graphics inside of them to produce in video output, because a normal CPU actually doesn't have graphics. So if you just have a CPU and no graphics card and plug it in, and plug it in, you actually won't see anything on your screen. Yeah, Jimmy, are you raising your hand for a question?
Is electric part of computers?
Could you repeat that please?
You
Sorry.
said is electric part of computers?
Is electricity a part of computers? Definitely. The electricity, we'll learn later, actually, the component is called a power supply, or an AC adapter. So basically it either the AC adapter charges the battery, or your power supply is plugged into a wall and creates power, in order to deliver power to these essential
So
components.
to answer your question, Jimmy, yes, there is.
To these essential components such as the CPU, GPU, or motherboard. Yeah. So the two main CPU chip manufacturers in the world right now are for desktop gaming, or PC gaming or not gaming, just PCs and desktops, computers are Intel and AMD. That's just something to know. Maybe you're interested in making a computer one day and you'll build one like me there. But if not, no one's really forcing you, so you're fine. Okay, next slide. So Gary, you can talk about this one.
Yeah, sounds good. So the next slide is called the GPU. Now, basically, what the GPU is, it's a graphics processing unit. So basically, this is like one of the key components of a computer. This is where all your graphics, basically your screen, your frames per second, things like these, is being processed. So what a frame per second is, right, is, let's say you're on a computer, right, and you have a mouse and you're moving your mouse around. It's very smooth right now because you have, let's say, for example, a good graphics processing unit, a good GPU. But if you had a bad one, for example, and it wasn't in the best condition and you had it in your computer, your mouse wouldn't be moving like it looked like Ivan's, for example. So your mouse was moving kind of chunky and it wouldn't be the best. But like
that's because frame rates actually translate to how many like how many times the computer refreshes what's on the screen per second. So that's also known as the for a monitor, that's known as it's the frequency, the refresh rate. So if you get a refresh rate with a 60 hertz refreshed monitor, you'll only see it'll only refresh 60 times a second. But if it's 144 hertz, it'll refresh 144 times a second. So that's just something to think about when you're buying something. But your graphics processing unit really allows like your images to kind
Load
of
up.
load up and look better depending on if you're playing a game. But yeah, it just basically it gives a video signal to your monitor or TV or whatever you play on or work on, and it gives you like an image. Okay, and then we'll move on to RAM, which is random access memory. So like earlier, it's kind of like the closet that stores information that's ready to go and that the computer knows that you'll be using. So what's stored here, you can, when your computer needs it, it goes through the motherboard lanes, and then the CPU processes what's there, and then it shows up. It's the video signal is produced by your GPU, and it shows up on your screen. So RAM can look like anything for like with RGB on the right to anything just kind of more dull for servers or workstations on the left. And then we'll go to motherboards, which Gary can talk about.
Yeah, so the motherboard in its name, right? It's like the mother of everything, right? So like it's the most important part of a computer, right? Because it controls basically everything. It's like the brain, for example, right? So the motherboard is basically this giant platform that connects to all the parts of a computer. So, for example, the motherboard connects to the CPU, uh, aka the central processing unit. It connects to the GPU, the graphics processing unit, things like these, right? It connects to things like memory. It connects to like hard drives, video cards, sound cards, all these other ports, right? Because remember the name itself. Remember, it's called the motherboard. It's in the middle. It's like the brain, and so it basically allows the whole entire computer to function.
Yeah, to add on to that, it's kind of like a highway. Imagine your components such as the RAM, the CPU, the GPU. Those are all of your cars, the main components. And they're like more like the parking lots. And then information is sent from there through the motherboard, which is the highway, into other components. So from the RAM to the CPU to the cars from the RAM, or the information is traveling through the motherboard to the CPU so it can be processed. That's a better analogy, maybe, I think. Okay, we'll move on. And storage. Storage can usually comes in either solid state drive form, SSD, or hard drive form, HDD. And so basically, an HDD is kind of a little bit more outdated version of storage because it actually has to physically move to write stuff on the disk. But an SSD is actually much faster and more efficient. It's actually more stable as well. Keeps your data safer to some extent, yeah. Next, we'll move on to the power supply.
Yeah, so the power supply, this relates to the question that Jimmy was asking earlier. Does a computer have electricity? Yes, it does. And this is where it comes in, Jimmy, and everybody else as well, right? The power supply contains electricity. You can see 850. That means 850 watts, basically the amount of electricity it holds to power the computer. And so basically what the power supply does, the PSU, also known the power supply unit, it converts all the electricity. Sorry, my bad. It converts all the electricity from the PSU, which is this power supply, to the computer and all the parts.
Yeah, so basically the power supply is theoretically kind of what's powering your whole computer, and this is for a power supply is normally for a desktop computer. The rating
Ivan.
Sorry, did Ivan cut out for
Thing
everybody?
on the side which 850, it's how much
Ivan, you cut out
theoretically provide to
everybody.
your
Ivan,
system in best conditions.
Ivan,
So, yep. Hello.
you cut out for everybody. You're gonna have to repeat what you said.
Can you hear me now?
Yeah, we can.
Okay, so basically,
So funny.
the power supply, it's normally never going to hit the rating of wattage. That's for ideal conditions. So you kind of want to aim for a power supply that's maybe higher wattage than a bit higher wattage than what you need. So that says a bit higher wattage than what you need. So you're for sure you know that it's going to work. Okay, next we're going to do it's going to be AC adapter. So this is for laptops. So you're plugging this into the wall and then into your computer to kind of power your laptop. There aren't any power supplies in laptops, as power supplies are actually quite big. So it's just easier to have an AC adapter into your laptop and a battery that stores electricity. Great. And then I think, Gary, you want to talk about cooling?
Yeah, sure. So cooling is the final part of computers. Like Jimmy once mentioned again, you have the power supply, right? It heats up the computer's running, all the parts is making the computer extremely hot. So what the cooling does is that these fans cool down the inside of the computer and make the computer cool so it doesn't lag, it doesn't explode, it doesn't get damaged. So it cools the computer down so it can run normally again without any lag. Yeah, Ivy, you want to add to that?
No, that's good. Computer parts generally get very hot. Um, yeah, computers get hot, they emit heat, and a form of cooling for a CPU is called CPU cooler, or a GPU can be a GPU cooler or the heatsink, which is kind of like another tool used. It's kind of like you're connecting pieces of metal, usually, I think, copper, or a conductive, copper, and that kind of transfers the heat away from the CPU and into the ambient air or the air, so it cools it down. And on the right on the picture is an AIO, so it's an all-in-one cooler. So basically, there's like water or coolant inside from the pump. You see the kind of the octagon kind of shape on the left, and there's tubes that are cool, and there's liquid in there that's cooled by the fans, and then it goes into the octagon, which is where you put on the CPU and it cools your CPU. There's radiators like that cool your GPU as well. So yeah, it just keeps your main components cool. And for a desktop, I don't know if I wrote that. Well, we'll just talk about here. For a desktop PC case, there's fans as well. As you can see, the kind of the circular things that keep your computer cool as well. But in a desktop PC, you kind of need an extra thing, which is kind of a case to hold all your components. So that's crucial as well. Or you can, I know someone who's actually just used a cardboard case for their PC. It works, but if you want it, it's not the best for function or like aesthetics as well. So the last part is I/O. Gary, if you want to talk about it, or I can talk about it.
Yeah, you can talk about it.
Great. So I/O is kind of the input and output of your computer. So on the left and right of your, or maybe even back of your laptop, or the back of your PC, desktop PC, there's an I/O shield, or I/O, which is input/output for short. And this is where you're able to connect a mouse to your PC using USB, or have video outputs such as through DisplayPort or HDMI. And it's kind of just to either have output from your PC or connect things to your PC or computer. So great. We actually have a video now, so I think let me share sound, and we will watch the video together. And then for this, you can turn off your cameras if you want. It'll just be a short 5-minute video, and after this, we have oh wait, give me a second. We don't have enough time. Let me do some math real quick. Actually, we talked about the evolution of kind of hardware. So maybe I I don't know, Gary, what do you want to do? Do you want to like just move to the next video or talk about?
Yeah, let's just watch the last video and then wrap it up for the end.
Yeah, but this one's just talking about how over the years computers have changed in order to have better visuals for games, have higher frame rates, have a better experience. But that's basically it. If you wanna, maybe I'll put the link in the chat. If anyone's interested, just let me know and I'll put it in the chat and you can watch it in your free time. But yeah, we're not gonna watch this right now. So we'll just watch this one, the evolution of software. Just if you can't hear the sound when I play it, just let me know.
In today's world, most of our life is spent on our electronic devices. Whether you're surfing the net with your smartphone, amending a presentation with your computer, or blasting aliens with your games console, you're using something that runs on software. We give computers instructions through the software interface. These instructions are then translated by the software into a language that the computer can understand. Before software as we know it, there were several early attempts at programming computers. Punch cards were the first. These cards were simple paper cards that had rows of dots. If the dot was punched, it represented a 0. If it wasn't, it was a 1. These cards would later be replaced by reels of magnetic tape. Magnetic tape took up far less space since storing stacks of cards was very impractical. It was still no easy feat to program. The actual term software wasn't used until the late 1950s. Many of the early pieces of software weren't available commercially. Instead, computer users, mostly scientists and large businesses, often had to write their software themselves. In 1954, the transistorized computer was introduced, but serious commercial systems did not arrive until the 1960s, leading to mainframes like the IBM System Series, a substantial jump in computing abilities. In 1970, an IBM researcher described how data could be stored in tables of related rows and columns. The idea revolutionized the IT industry. IBM began selling software in the late 1960s and early 1970s. It meant that data structures could be standardized so that different programs could use the same data. This was the first time commercial software was available to the average customer, and the ability to add different types of programs to any computer quickly became popular. In 1970, the first microprocessor was developed by Intel as a cheap way of making general-purpose calculators. This little gizmo led to the microcomputer revolution of the late 1970s and 1980s. When computers became small enough to be sold to individuals, software became much more prevalent. Home users couldn't program their computers themselves. Instead, the operating system was created. In the early 1980s, IBM selected a small company called Microsoft to provide their operating system. Microsoft MS-DOS was licensed to IBM. For every IBM PC sold, Microsoft would receive $40 US. Microsoft was on its way up. Through the 1980s, spreadsheets, word processing, and PC database applications led the way, with Apple also now a major player in the PC and OS markets. Software became more and more complex over the years. In the early days, commands were typed in, and early software only accepted keyboard input. Because floppy disks could only hold a very small amount of data, and most personal computers had no actual hard drive, software had to be very simple. That changed as computer hardware evolved. By the 1990s, microcomputers began filling old mainframe computer rooms as servers, and the rooms became known as data centers. The continued rise of the internet allowed for the development of virtual data centers by the end of the decade. CDs could hold much more information than floppy disks, and programs that were once spread across a dozen floppies fit on one CD. The creation of DVDs, which hold even more than CDs, has made it possible to put bundles of programs, such as the Microsoft Office Suite, all on one disk. Now even DVDs are becoming obsolete. Many people purchase and directly download their software. In 2006, Amazon Web Services began offering IT infrastructure services. Increasingly, vendors are now moving to software as a service, SaaS. a software licensing and delivering model in which software is licensed on a subscription basis and is centrally hosted. Overall, from 2015 to 2020, IT spending on enterprise application software will grow at an 8.6% rate. SaaS growth will be 19.3% and can be expected to reach $76 billion by 2020. The rise and establishment of the Internet of Things, IoT, is driving even further expansion of enterprise software. It is estimated that within the next 5 years, there will be more than 25 billion devices, sensors, and chips, handling upwards of 50 trillion gigabytes of data. That's more grains of sand than you'll find on this tropical cartoon beach. Software has come a long way, and the importance of software is now paramount to a company's success. Speak to License Dashboard on how we can support you to manage your software today. And
Yeah, so that's a short video. How do I need to exit this full screen? Okay. Give me a second. Give me 1 second. What is happening? Okay. We're almost done. Great. Now let's go back. Nope. Okay, so we're at the end of our lesson. I hope you guys learned something today. So we're actually going to do a little bit of personal reflection, group reflection for what we've learned today. So Gary, if you want to take it away.
Yeah, all right. Sounds good. So thank you everybody once again for coming today. Spending your Sunday night here. I know some of you don't want to do it, but for everybody here, thank you for doing it. We do really appreciate it. You're already one step ahead of all your friends because you were willing to take the time tonight to come and learn about these. So you're already probably smarter than your friends about computers. Yeah. But without further ado, let's begin the end. Yeah. I don't know how to phrase that, but what is one thing you guys learned today? We just need, let's go one or two person for each question. You guys can choose if you guys want to answer that one or not. I'll have to call on you if nobody answers within the
I
next.
want to.
Okay, sure. Sounds good. What did you learn today?
I learned about, I think, computer was made in 1936.
Nice. Yeah, good job. Yeah, exactly. Computers were made exactly in 1936. So good job. You actually remembered that. Good job. Good job. You remembered that. And does anybody else want to share? Ivan, should we go for one more?
I think it might have been 1938, but
No, 1936. 1936.
Oh,
First ever
okay.
computer. Yeah, 1936.
Never mind.
If
I don't
nobody
know.
else wants to share, Ivan, why don't you pick on one then?
Okay, let's do. Jimmy's been asking a lot of questions, so let's do. Wait. Let's do Freya. Freya. If I'm saying your name wrong, just let me know. Could you answer a question, please?
If not, that is okay. We're gonna move on then. Does anybody have any final questions? Seeing that there is none, we want two people to answer this one. What would you like to see done next week about computers? Anybody? Or like internet in general? What do you want to learn
I
about
want to learn about things that are
So do you want to just learn about how the internet and like
I want
computers
to
relate?
learn about the electricity.
All right, yeah, we'll take that into account. Thank you for your suggestion. Anybody else? Seeing that there is no more and it's already 8:30. I hope you guys learned something today. And yeah, I hope you guys have a good night. You guys are free to go now.
Yeah, thank you for coming out. We really appreciate it.